All right, ladies and gentlemen, good morning, or maybe it's not morning where you are or when you're watching this lesson, but it is morning for me here. So welcome to the next part of Unit 10. This one's going to be a little bit shorter because it's pretty much all calculation. What I'm going to teach you today is how to put different types of numbers to convey how concentrated or dilute a solution is. And we've already talked about this a little bit in the first lesson for this unit. I introduced you to the concept of molarity. And the reason that I sort of singled that one out is because that is the most common way of expressing a solution's concentration, but it's not the only way. There are other ways: molality, percentage, something called mole fraction, and I'm going to teach you how to calculate those numbers today. So on the note sheet that hopefully you have in front of you, okay, there are at the top of the page these four concepts that I just talked about, and their formulas are there. Okay, now I know we've already talked about molarity, but it's worth reviewing. Okay, molarity is calculated by dividing moles of solute by liters of solution. Let's review for a second. Let's review some vocabulary. Solute is the substance that is being dissolved. Solvent is the substance you're putting the solute in. So if I'm dissolving sugar in water, sugar is my solute, water is my solvent. When you put the whole thing together, we call it the solution. Okay, so we've already looked at molarity. There are other ways. Molality, which is abbreviated with a lowercase m, looks very similar, but moles of solute, same numerator, but different denominator. Kilograms, not of solution, circle that in your notes if you need to, kilograms of solvent. Be real careful with that. Percent by mass, mass of solute over mass of solution, mass of the whole thing, times 100. And mole fraction, this looks a little bit confusing. This part here where you see these little A's and B's, okay, A and B represent solute and solvent, okay, so what's in the numerator here, okay, it's not letting me draw for some reason, what's in the numerator is moles of solute. What would be in the denominator would be moles of solute plus moles of solvent. Okay, please notice there is no times 100 like in the percentage. Okay, mole fraction is not a percentage. It's very similar, but it's not a percentage. And if you think about, what are the units for mole fraction? Mole fraction is moles divided by moles. So the unit of moles actually cancels out. A mole fraction is just a decimal number with no units. It's a unitless entity. Okay, so let's look at an example here. Okay, this is the same example that you have in your note sheet in front of you. And what I'm going to ask you to do is actually not look down at your notes, but look here. Look on the screen at this example. It's the same one. And I'm going to kind of talk you through how you would do this. Okay, it says a solution is prepared by mixing 12 grams of ethanol with 100 grams of water to give a final volume of 115 milliliters. Calculate the molarity, mass percent, mole fraction, and molality of ethanol in this solution. What I recommend is whatever you're supposed to be solving for, write out what goes in the numerator, what goes in the denominator of what you're trying to find. and see, okay, how do I find those two pieces? So, for example, we're going to start with molarity. Molarity is, if I can get this to write, moles of solute over liters of the whole solution. Okay, anytime you see me write SOL apostrophe N, that's my shorthand way of saying solution. Okay, so let's look at the information that we are given and let's think about how do I find these two pieces. We're going to treat ethanol as the solute and water as the solvent. Okay, so I need moles of ethanol, all right, which the problem did not give me, but I can get it. All right, so I'm going to say 12 grams. Oops. Let me go back here. And I'm going to convert this to moles. Okay, I'm going to use the molar mass off the periodic table, which is right around the neighborhood of 46.1. Okay, and I'm not going to round too much. That's going to give me this many moles of ethanol. Okay, so I've got my moles of ethanol. Now I need liters of solution. If we look back up in the problem, it said the final volume was 115 milliliters. Well, how many liters is that? 0.115. Okay, so now I have all the pieces I need to solve this problem. So 0.26 moles divided by 0.115 liters, round my answer, and there's my molarity. Okay? All right. Now, let's move on to the next one. What do they want us to solve for next? Mass percent. Okay, this one's usually pretty quick and easy. All right, so again, I'm going to write out what it is I'm supposed to find. Mass percent, I need grams of solute, and I need grams of the whole solution times 100. Okay, fine. Well, this one will be quick because I have 12 grams of solute. Okay, now be careful, this is grams of the whole solution, so it's not 100, it's a 112 times 100, and just as we usually do, guys, let's round our percentages. I know it doesn't show this in the notes, shame on me, to 1 decimal place. And there's my answer, 10.7. Okay. Let's move on to the next one. Mole fraction. Okay, I'm going to write out my fraction of what is it that I need here. I need moles of solute, and I'll just write total moles. Okay, and mole fraction, we don't multiply times 100. If you look back at your work from before, I already have the moles of solute. I calculated that earlier in this problem, so I'm just going to write that down here. 260, we had moles of ethanol. Okay. But I also need moles of my solvent to get my total moles. I've got 100 grams of water. And I'm going to change that into moles of water. And let's see, that gets me somewhere in this neighborhood. Okay, and that's moles of H2O. So let me come back down to the bottom here. I've got moles of solute in my numerator, and in the denominator I want moles of solute plus moles of solvent. Don't multiply times 100, mole fractions, we don't do that. And I'm going to just keep it as a decimal. No units. 0.0447. Okay. All right, last part. Let me erase all this. This time the last thing we're supposed to find is molality, which is moles of solute over kilograms of solvent. Okay, now this one also should be pretty quick and easy. We already found the moles of solute earlier in the problem. Let me just write that down. Okay, kilograms of solvent, not solution, just the solvent, which is 100 grams of water. 100 grams is how many kilograms? 0.100 kilograms. And we divide that out, final answer. And you can just abbreviate write your units with just a lowercase m, like that. Okay? So again, these problems are not hard. What I would recommend is writing out fraction style, what you're supposed to be solving for, and asking yourself, okay, how do I find the numerator? How do I find the denominator? Find each piece individually, and then divide. So here's what I would suggest that you do. If you look over at the homework questions, you will see some headings. The first one says percent solutions, the next one says mole fractions, and then over on the next page there's a heading that says molality. In those 3 sections, what I would do is pause the lesson and do questions 1 and 2 in each of those subsections. Do 2 from percent solution, 2 from mole fraction, do 2 from molality. The only reason there isn't a special section for molarity is because we did that on our last lesson. So pause now, do those 6 problems, check your answers, and then come back. Okay, what I want to do for you before we finish out these notes is I want to do a problem from the homework with you. If you go to the end of the problems, there is a section that just says mixed problems. Okay, and I want to do one with you. I want to do number 1. Because this is more like the type of question you would see like in on a test, or especially if those of you that go on to take AP Chem, they will look more like this. Okay, so let's look at this first mixed problem together. It says calculate the molality. Okay, I'm going to stop there, and before I go any further, I'm going to write out my fraction of what I'm supposed to find. Molality is moles of solute over kilograms of solvent. Okay. Calculate the molality of a 20% by weight aqueous solution of ammonium chloride. Okay, let's break this down just a little bit, okay? Let's review, what does the word aqueous mean? Aqueous means water is the solvent, okay? Which means ammonium chloride is my solute. So you know what? I'm going to make this a little bit more specific. I'm going to erase this and I'm going to make this more specific. Moles of ammonium chloride, kilograms of H2O. Now I know exactly what it is I need to find to solve this problem. Okay, now come to the number. It says 20% by weight. Well, guys, if you think about that, what that really means is that I have a ratio here. 20 grams of ammonium chloride for every 100 grams of the whole solution. I know I can do that. I can just write that fraction out. If it's 20% by weight, by mass, I know that this ratio is correct. I am going to use these two pieces of information to help me find these two pieces of information. But let's take it piece by piece. Okay, first piece I need is moles of ammonium chloride. Okay, no problem. All I've got to do is change 20 grams of ammonium chloride into moles. And I don't have this number right in front of me, but I can get it real quick. Okay, so the molar mass of ammonium chloride is 53.5 grams. Let's divide that. Okay, I'm not going to round too much. 374 moles. And that's ammonium chloride. Okay, so cool. I've got the numerator of what I need to solve this problem. Okay, well, I also need kilograms of water. Come back up here. If I have 100 grams of the entire solution and 20 of those grams are made up of ammonium chloride, how many grams must be made up of water? 80. 100 minus 20 is 80 grams of water. Well, how many kilograms is that? So 80 grams equals 0.08 kilograms of water. And now I'm ready to solve the problem. Okay. And let's see, I'm going to look back at the original problem. I'm going to round to 3 significant figures. And it's a molality, so I'm going to write a little m, final answer. Okay. In these mixed problems, okay, what I really suggest doing is exactly the way I started this problem. Write out the fraction of what you're supposed to be finding and write out a fraction of the information that you're given. Okay? If I was, let me just draw a little squiggle line here. Let's say I was given a problem where I was given a molarity and I'm supposed to change it into something else. Okay? Don't leave that given molarity just as whatever that number is. I mean, let's just say, I'm making this up. Let's say the problem said the solution was 4.5 molar. Don't leave it written like that. Write it like this. Write it as a fraction. 4.5 moles of the solute over 1 liter of the whole solution. Whatever given information you are given in the problem, don't leave it like that. Write it as a fraction. I find that method to be a lot easier because then it gives you not just one piece of information, but two pieces of information to work with. Okay, that's just my suggestion. All right, let's finish out this chapter. Okay, or sorry, not the chapter, just this lesson. The last section, and this is probably a pretty easy part, is something called dilutions. Okay, and this is a skill that I use all the time when I'm making solutions for you guys when we do labs. Sadly, when we used to do labs, I use this math frequently. Okay, so here's the situation. All right, and we're going to do an example problem in just a minute. Let's say we're working with, hydrochloric acid, and for the lab that we're doing, I need to make some bottles of 1 molar, so molarity, hydrochloric acid solutions that are 1 molar. So I go back into the chem storeroom and I look in our acid cabinet and I pull out what's called a stock bottle. Okay, which means an ultra concentrated version of that solution. And I pull out the bottle, and the bottle says that stock solution is 12 molar, which is way too concentrated. I would never let you guys work with something that concentrated. And so I say to myself, okay, I've got to dilute this. The question is, how much? All right. So if you have something that is too concentrated, I have this 12 molar acid and I need it to be 1 molar. How do you fix that problem? You add water to it. Okay, but there's a method to it. All right. So, and I'll talk about this picture that's on the screen in just a second. There is an equation that you use, and you only use this when you're doing dilutions. Okay. M1V1 equals M2V2. M stands for molarity. V stands for volume. Okay. I want you to think of one side as being for the stock solution, the solution that is way too concentrated, and the other side as being for your diluted solution. Okay. So what I would say is, okay, to do this lab that we're about to do, I want my solutions to be 1 molar. That would be M2. For all of my classes to do the lab, let's say I need 500 milliliters total of that diluted solution. The stock solution that I have to work with is 12 molar. That would be my M1. V1 would be my unknown. So let's look at this picture. Okay, this piece of glassware that they're showing you in this diagram here, this picture, is something called a volumetric flask. And its one and only job, its one and only role is for making solutions. Okay, you'll notice that this volumetric flask in the very first part of the diagram, in part A, there's already a little bit of water down in there. That is for safety reasons. Whenever you make acid dilutions, you always want to add the acid to the water and not the reverse. I won't get into the details of why that is, but it can be very dangerous and generate a ton of heat if you do it in the other direction. You'd think it wouldn't matter, but it does. So there's a little bit of water down in there. What's up at the top of the picture, that's something called a pipette. Okay, don't call it a pipette, that bugs me. Okay, it's called a pipette. We've done the math. We would have solved for some number for V1. That would tell me how much of that concentrated solution do I need to pull out of that bottle. That's what's in the pipette. Okay, and let's actually, do that math. Okay, the stock solution was 12 molar. V1 is my unknown. The concentration that I wanted was 1 molar. and I wanted 500 milliliters total of that solution. So if we do the math here, 500 divided by 12, this is what I get. Okay, so that number is how much of the stock solution I'm going to measure out with my pipette. And I'm going to add it to the volumetric flask. And you'll notice in part B of this picture, I'm not up to the line yet. That line represents 500 milliliters. And you'll notice I'm not in part B. I've added a little bit of water. I've added my 41.7 milliliters, but I'm not up to 500 milliliters yet. So you fill the rest of the way up to that line with water. And what you're seeing in part C, that would be exactly what I wanted to get. 500 milliliters of a solution that is exactly 1.0. Okay, so that's how this math works. Okay, and let's just look at, this is the example problem that is in your notes. Okay, and this is real stuff. I do this all the time. How much concentrated 18 molar sulfuric acid is needed to prepare 500 milliliters of a less concentrated 6 molar solution? Okay, so M1V1 equals M2V2. Remember, make one side, and it doesn't matter which side. I always do the M1V1. I always make that my stock solution, the one that's more concentrated. Oops. 18 molar. I don't know its volume. And I always make the M2V2 side the more diluted solution. So I want 6 molar, and we want 500 milliliters. Okay, your unit of volume does not have to be in milliliters. It can be in liters. It really doesn't matter. As long as your units are the same on either side of the equal sign, it does not matter. So I get 166.66666. I'm going to round that to 2 sig figs. So this is how much of the concentrated stock solution I would need to make this solution that I desire for my lab. And that's it. So take this time now to finish up any of the problems that we didn't get to. Check your answers, and I will see you guys at our next lesson. Take care, y'all. Bye.